In today's video, we're going to be taking a look at some hand and face gesture experiments that I have performed. Here we are seeing two hands being detected, tracked, is influencing a 3D environment, just like this. Let's take a look at the next example. This one is a voice chat with Groq by pinching and moving. Groq actually responds. Groq actually generates the text. We display it on the right side, and we also get OpenAI TTS to actually speak it.
A mysterious,
I'll let you listen to
undeciphered
it
book from the 15th century.
for a moment.
I came across it while processing.
You can just click drag. This is some of my experiments to create new UIs, UX experiences.
Yes, the Voynich manuscript's cryptic nature and lack of a deciphered language make it intriguing. Its strange symbols,
These are currently just experiments, but I'm still working on them.
the
Let's take a look
botanical
at another.
illustrations.
This next one is a face detector, face expression detector. Plus, it actually analyzes the emotions that are being detected entirely in JavaScript, no server necessary. It's pretty beautiful using media libraries, JavaScript libraries. We'll talk about the code more, and also I will just generally explain how these things work. But you can download the code files for these from my Patreon. I actually created a two-hand detecting template as well. You can find all the links in the description and the comment below. So if you pay attention here, the expressions or the emotions are being detected in real time. Pretty cool, I thought. Next up is a hand gesture art maker. It can track the fingertip movements of any finger of any hand. You can actually adjust it here in the side panel, along with hand visibility and trail strength. The hand detection is actually being displayed on the top left. Pretty cool stuff, really. These are all to demonstrate all the new stuff I learned in the last few days. Very exciting stuff. Now here's a free hand gesture detection template I've created. This is full stack and fast API. The reason why it's full stack and it's freely available at my Patreon, like I said, these are okay. Before moving on to the next one, the previous one is just a template. It's a full stack template because so this way, if you wanted to create a hand gesture UI and UX web app with using large language models, just like I've done with Groq by pinch dropping, text boxes, you can actually easily use that. Fast API really makes it convenient. So here we are seeing another example, which is just pinch moving objects. It works really well. Like I said, these uses media pipe library. There's a JavaScript version and a Python version of this. And there's also some other libraries that actually build upon the media pipe library. One of them I use for the face emotion detection is called Human. So let's talk about them real quick, and then I will let my AI code explainer review one or two of these code pieces. And you can also download the AI code explainer from my Patreon as well if you like it. So let's take a look. Here we are looking at the CDN scripts that we have used for the hand grid visualization, the one with the 3D bars that are being interactively moved by the movement and position of two hands. As you can see, we are using media pipe library. Comes with quite a lot of utilities and 3JS here. So this is a single file HTML, and it essentially just uses these CDN libraries to do all this. I was very surprised that all this was possible. So here we are looking at the CDN imports, I should say, or the scripts for the human face detection and emotion detection. Again, we are using media pipe libraries. For example, it can draw a face mesh and whatnot. And we are using the human.js to actually detect the emotions. So here we are looking at the human library. It says AI-powered 3D face detection, rotation tracking, face description, recognition, body pose tracking, iris analysis, age and gender, emotion prediction, gaze tracking. So this is important, I guess. I will be making more demonstrations of these later. I also have been doing them actively in my X profile if you like to visit. So this is pretty amazing, but these libraries are updated, created and updated pretty recently, and latest cloud knows about it, but it's not very great. So you'd have to do some copy pasting, some of these code examples, and really work with it by prompting it to get it working. But let's go on now, and I will actually review the code files. I will let my AI code explainer explain the code files for the free two-hand gesture analyzer full stack web app, and also I'll let it do it for the face detection and emotion analysis. Those are single file pages. And like I said, if you like to download them, you can download them for the template, two-hand detection template for free, and others are at different tiers at my Patreon. Link will be below. Let's begin.
This initial segment sets up the foundational structure for our web application using FastAPI. FastAPI is a web framework that allows for quick and correct building of high-performance web apps. After importing the necessary modules, we set some constants like host, port, and reload, which will define how the FastAPI server runs. The FastAPI app instance is initialized with a title, description, and version, serving as metadata for the application. A crucial part here is the mounting of static files using FastAPI's static files, which allows the application to serve static resources like JavaScript, CSS, images, etc. While the code serves its utilitarian purpose, it's also laced with some colorful print statements thanks to term color, adding a little visual flair to our console logs. Just in case mounting the static files fails, an exception is raised after printing out an error message. This setup is foundational because serving static files is essential for any web application, especially for one involving hand gesture detection. This segment focuses on setting up the template rendering part of the web app and creating the route to serve the main page. We're initializing the use of Jinja 2 templates, which is a templating engine for Python, allowing us to dynamically generate HTML by passing data to templates. Following this, we define an async FastAPI route function using the decorator at app.get/. This function route handles requests to the root URL of our server, serving the main page, index.html, where the hand gesture detection will happen. The request object must be passed to the template to correctly render the page. If there's an error while serving the page, the code logs the error and raises an exception. Like the static file setup, there's a dash of color in the console output. This snippet is critical for displaying the user interface where users will interact with the gesture detection feature. This snippet is dedicated to handling the startup event of the FastAPI application. By decorating the startup event function with @app.onEventStartup, this piece of code ensures that certain actions are taken as the server starts. It basically functions as a go-time cheerleader for when the server is ready to roll, providing some informative print statements, indicating server host, port, and whether or not it's set to auto-reload. The use of term color keeps the morale up with colorful, easy-to-read messages, a little bit of UI splash for your command line. This code is important because it helps manage the server lifecycle, alerting developers to key status information right as the server boots up, ensuring they head off any issues early on. This segment wraps up the Python server section by providing both a shutdown handler and starting the main application. The shutdown event function, decorated with app.onEventShutdown, serves up a friendly reminder that the server has been stopped, complete with a waving hand emoji, because who said code couldn't be cordial? The if Groq name equals main block checks if the script is run as the main program and not imported as a module. If it is, it uses Uvicorn to run the FastAPI app. This part is responsible for executing the server with specified host, port, and reload settings. Like previous blocks, it provides detailed error logging if something goes wrong, because nobody likes surprises when deploying. This entire segment is essential for both initializing the application server when the script runs and handling the graceful shutdown of server processes. With both startup and shutdown processes in place, the server can manage its lifecycle events effectively. This segment is the index.html file written in HTML, which defines the structure and components of the user's interaction space within our hand gesture detection app. It's a crucial component of the UI that users will see and interact with. The head section includes linking to external CSS for style, thanks Tailwind CSS and Daisy UI for making it look modern and chic. And JavaScript libraries, like anime.js for fun animations and necessary libraries from MediaPipe for high-fidelity hand tracking. The body contains key elements such as a welcome banner, status displays for hand detection, and the real stars of the show, video and canvas, which handle the live video input and rendering the hand gestures, respectively. This live feed will eventually be processed to track hand gestures. Finally, the script included towards the end, handtracking.js, is where the hand detection logic lives, a separate JavaScript file housed in our static files. All this structured HTML helps bring life to the static page, allowing users to engage with hand gesture detection seamlessly. In this JavaScript segment, we kick off the client-side logic for the hand gesture detection process. Key elements such as video input, the drawing canvas, and status displays are selected from the HTML document and set up as constants. Several variables track the state of the hand detection process, such as isTracking, which will help manage whether the app is currently analyzing the video feed, and placeholders like camera and hands for respective MediaPipe objects. The initialize canvas function dynamically sets the video and canvas dimensions to align with the window size, ensuring everything's visible and correctly proportioned. A vital step given that this is a visual application where seeing is believing. The draw hand function is responsible for the visual representation of detected hand landmarks and connections. This is where we translate MediaPipe's data on hand positions into visual markers and lines on the canvas, making sure both left and right hands leave their trails in vivid colors. This rendering magic transforms raw data into something users can visually comprehend. This snippet lays out the primary job of processing the results from MediaPipe's hand tracking. The function onResults acts when MediaPipe hands provide new analysis data from the video feed. It first checks if tracking is active, an essential step to preserve your canvas's resources. Then, the function wipes the previous frame from the canvas to prepare for drawing anew, ensuring no ghost hands are left in view. Each detected hand's information is processed to update the left and right hand detection statuses and then visually represent each hand's landmarks and connections via the draw hand function. It cleverly distinguishes between left and right hands through labels and updates status texts to reflect the real-time detection results. The importance of this function is that it connects the raw image processing capabilities of MediaPipe with the visual feedback in the application. It is here that the complex data is distilled into something easily interpretable by users, indicating clearly whether their hand movements are being detected in real time. This segment is tasked with initializing the MediaPipe hand tracking system, the MVP of our hand gesture application. Initialize hand tracking is an async function that sets up MediaPipe hands by configuring its tracking parameters, like the number of hands to track, the model's complexity, and confidence thresholds for both detection and tracking. These options tailor how the system works and its performance trade-offs. Hands are detected continuously as the video feed frames are sent to the MediaPipe hands model by a camera instance. The onResults callback is attached to handle the visualization and feedback in near real time. Any initial loading visual is hidden once the setup is successfully completed, indicating to the user that they're ready to wave away. This initialization phase is vital because it sets up the connection between the live video feed and MediaPipe's powerful hand analysis capabilities, configuring parameters and kicking it all off with UVC camera feeds. The last segment is a simple yet important feature of any interactive UI, event listeners. Here, 2 event listeners are set up. One kicks off as the window loads, initializing both the canvas size to fit the window and the hand tracking system, effectively serving as the entry point once the browser fully loads the app. The other event listener dynamically adjusts the canvas size whenever the window is resized, ensuring flexibility for users who decide to resize or even maximize their application window. These listeners ensure that the application properly initializes and remains responsive to layout changes, enhancing user experience and application reliability. This segment of code sets up the initial HTML document and includes critical libraries and styling resources needed for the face gesture and emotion detection application. It begins by defining the basic document structure and metadata, such as character encoding and viewport settings to ensure responsive behavior. It then imports several external scripts essential for the application's functionality, like MediaPipe for facial recognition and a custom CSS framework for styling. The custom styles and animations, specifically for background and text gradients, enhance user experience visually. Additionally, configurations for Tailwind CSS are defined to expand its functionality with custom animations and ease integration with Daisy UI themes. These elements are critical for both the aesthetic and interactive components of the overall application, setting the stage for what's to come next. This section of the code constructs the application's front-end user interface. It includes a gradient background for aesthetic appeal, a sticky navbar for easy navigation, and containers for status display and emotion results. The status badge will notify users if a face is detected, while the emotions container is dynamically updated with the detected emotional states of the subject by adjusting to either show or hide the visual elements accordingly. The video element is invisibly recording the input necessary for processing face data, and the canvas element serves as the main surface for rendering facial mesh landmarks, making users feel like digital painters. There's also a debug panel for developers to display technical details without disrupting the user experience. Additionally, a hidden loading spinner component signals processing state, ensuring users aren't left wondering if the system is operational or staring into a digital abyss. This layout ensures an interactive and dynamic user experience where facial recognition and emotion detection components are clearly defined and accessible. This script segment is the brain of our operation, initializing crucial elements and defining a key function, update emotions, to process and render emotion data detected from the input video. We begin by selecting the HTML elements needed to display or process information, like our trusty canvas and video elements, where all the action gets painted and replayed, respectively. Then we establish specific dimensions for the canvas, promising clarity in the visuals. Moreover, the snippet sets up a color palette representing various emotions, because let's face it, the world would be pretty dull if everything had the same hue. When emotion data is detected from a face, the function processes these emotions, filters the relevant ones, and dynamically updates the UI elements to reflect and possibly amaze users with colorful emotion badges. It also provides debugging capabilities by displaying the detected emotions in JSON format, ensuring our virtual emotions never stay bottled up. Here we dive into the heavy lifting of emotion detection using the Human Library, a sophisticated toolkit for nuanced human perception tasks. This section initializes the library with the necessary configurations focusing on facial recognition and emotion detection, making sure it's not distracted by other body parts. Our focus here is on facial expressions, purely and simply. The Detect Emotions function serves as the core loop, continuously analyzing the video feed. Yep, it's like the digital Sherlock Holmes of the face, endlessly watching out for emotional clues. When a face is detected, it extracts the first face's information, capturing the emotional state and passing it along to be visualized. This ensures that bored or disappointed faces don't slip through unnoticed, maintaining user engagement and providing a vibrant user experience with immediate emotional feedback. Plus, async await is used to make sure all operations run smoothly without unnecessarily freezing the page, a developer's secret weapon against browser grumpiness. This snippet focuses on capturing and processing the structural details of the face using MediaPipe's face mesh technology. Like an artist rendering your digital likeness one pixel at a time, the onResults function is responsible for displaying the face mesh on the canvas by drawing connectors between key facial features in vivid colors, ensuring that even the drowsiest viewers can appreciate the art behind facial mapping. The face mesh object is initialized with specific configuration parameters. Max Num Faces restricts processing to a single face because we don't want our emotions too mixed up. Refine Landmarks ensures higher detail, and confidence values tune the robustness of detection. This orchestrated process of weaving digital threads across the face contributes directly to the program's aim of complementing emotion detection with visual guides, effectively tying together emotional states with facial structures for a comprehensive experience. This last snippet ties all the threading together, orchestrating camera access and kickstarting the face detection process right from the moment the page loads, as if it's eager to catch every blink you make. Here, a camera object configures the dimensions and process for capturing video frames that are analyzed for facial features. The init function handles the initialization process, loading the human library and starting the camera, your digital team behind the scenes ensuring everything is picture perfect, or, when things go awry, alerting the user about accessing permissions. The loading spinner is toggled for better user interaction, indicating when the stage is being set. Additionally, event listeners add delightful touches like toggling the debug feature with a mysterious D, key press, or handling device orientation changes to ensure the canvas is always showing its best side. This part of the code is all about ensuring seamless interaction between human gestures and the digital world, fulfilling the ultimate aim of making emotion detection as accurate and user-friendly as possible.
Listen to me, I've been trying to code, and I like coding, the fact that I can code and make things happen, but how do I do it? I mean, fast, with AI. I heard about it, it's easy, so I came across 1000x cursor course. And that's great, it just made everything super silky smooth. It just worked. I'm telling you.
1000x your coding.